everyone, and welcome back to our course. In this section, we are going to learn how to build a game with C++ in Unreal. So join me in Unreal 5. I have launched the Unreal 5 engine. Here I'm going to select a game template for my starting point. You could use a blank project with absolutely nothing to help you start with, or you can choose from some of these templates which have some pre-built functionality already inside of the game to help you get started faster. For this project, we're going to be using the first person template. This will allow us to have some basic first person controls already implemented in the game. We could do all that from scratch, but it's not required. With these templates, we can get up and running really quickly. For the project defaults, select C++ as the project type. Note that it doesn't really matter which one you choose. You could use Blueprint or C++, but we're going to choose C++ because that is what we're going to be using to build the game functionality in this course. But even if you chose blueprints, you could add C++ after. The target platform will be desktop. Quality preset will be maximum. We can enable starter content, but it's not required. This will give us some assets, materials, and textures for our game, and we don't need ray tracing. Then pick a location for your project and let's save it. I'm going to call this my first person shooter. Then press the create button, and that is going to launch the Unreal editor. Here we go, we have our template because the Unreal editor has launched, as has Visual Studio. We can press update in the bottom right hand corner to automatically update the project for Unreal 5. Right here we have our content folder. You might see other folders as well here containing all of the possible C++ classes. Here in the viewport, we can look at the contents of our game just by clicking the left mouse button, holding it, and then moving your mouse around. You can run around this game with your camera. Here we have some default cubes and rectangular prisms and this walled environment because we're using the first person template. If you press the play button at the top here, you can actually simulate the game. Okay, let me just drag the windows aside to make this a bit larger. If you want to move around in this game, just click once inside of your viewport here. Then you can use the WASD keys to run around, and you can click to shoot. Alright, so by default we have physics enabled on these cubes and collisions as well, because if I hit one of these cubes, they get moved around. Alright, and also I can shoot projectiles at objects and they'll bounce off walls and off of the cubes as well. And again, I can run around and jump with the space key. So this is what the game looks like just as the template. Right, so because we are using the template, we have this setup. You could build a completely blank project if you wanted to, but then you'd have to set up all these controls yourself from scratch. If you want to regain control of your cursor, then just hit Shift, FN, and F1 on your keyboard. Alright, now I can actually move my cursor around, and the game is still in play mode. If you want to stop the game, just hit escape or hit this stop key. Okay, so I can hit escape anytime. And that stops the game. I'm back in just the viewport mode. Alright, here we go. We have our template set up. As well, Visual Studio should have opened too. Let me just pop that open. Not only did Unreal open when I created the project, but so did Visual Studio because the project type was C++. Alright, so I can see in Visual Studio the different code of my template. If you go into source here and then go into first person shooter, you can actually see most of these are C++ files. One of them is a C# file, as well as this target C# files as well. If you click on one of these, like first person shooter character.cpp, which is the file extension for C++, here you can see some code is already pre-written for us, and that's because we're using a template. So this is all part of the template. For example, what happens when the character begins to play, and setting up all the input bindings to enable the player to jump and to fire, as well as to move. Alright, so we have a lot of pre-written functionality. Feel free to dig deeper into all of these files if you're interested in seeing how the actual template was set up. Looking at the templates is a great way to learn how you can set up the basic functionality for different types of games, such as a first-person shooter. We're going to be editing a lot of these files as well as creating our own C++ files. Now, if Visual Studio didn't open or didn't generate your project files, you can actually generate them manually. Just find your project in your File Explorer, then right-click on the Unreal project, and here select Generate Visual Studio Project Files. Alright, so you can generate the project files at any time. As well, make sure you do have C++ in Visual Studio. So you can at any time change what templates you have, what tools you have in Visual Studio by going to Tools and then Get Tools and Features. This will open the Visual Studio installer, even though we already have Visual Studio installed. So here we can actually install extensions to Visual Studio. For example, here I have game development with C++, and that's the one you want to make sure that you have. Because if you don't have game development with C++ here, then you won't be able to compile C++ code. Alright, so make sure you have that one selected. If you don't have it here in your installation details, it means you just have to find it in one of the components available, and then you can just add it to your installation. I also have Python, but that's not required for this course. That's just from a previous project. Alright, and now we have set up our project. Hello everyone, and welcome back to our course. One note about Visual Studio is in order to actually run and compile your Visual Studio projects with Unreal, you have to make sure you're running Visual Studio in administrator mode, which means whenever you open up Visual Studio, you have to right-click and make sure you're running it as an administrator if you don't have your default settings set up so that you're always running it as an administrator. Otherwise, if you don't have this run as administrator enabled, you can come up with problems where you don't have read and write permissions in order to be able to compile and send to debug the project in order to launch your project in Unreal with debug mode from Visual Studio. You can also just open up a project with administrator mode by using Shift and Control as you open the project. So you just hold Shift and Control keys on your keyboard as you open the project. So just keep that in mind. You do need to make sure you've enabled Visual Studio to run with administrator permissions in order to actually send that build to Unreal. You don't need administrator permissions just for writing code or building console applications, but for actually being able to hit debug and compiling the code that you wrote in Visual Studio with your Unreal project, you will need to make sure you're running in administrator mode. Join me coming up in our next lecture. We're going to write some C++ code as a quick win to get started. Hello everyone, and welcome back to our course. In this lecture, we're going to write our first C++ code for this first-person shooter game. It's going to be a quick win where we're going to write code for the projectile, where every time our projectile hits a cube, we're going to shrink the size of that cube. So for this, open up Visual Studio, make sure you're running it in administrator mode. And next up, we are going to open up the projectile file here. First person shooter projectile.cpp. If you called your project a different title, then that project name will be here followed by projectile.cpp. Here I've also increased my font size for you. And at any point you can also drag around windows like that, and you can rearrange the windows in Visual Studio. Alright, here we have our class for our projectile, which is that bullet that spawns from the first person shooter's gun. Let's go ahead and look for the function known as onHit. So I'm going to Control F and search here for onHit until I find that function. Here you go. We can see it's this void function. It takes in several different arguments here. We have hit comp. This is the component that was hit, which can be one of the cubes in the scene or any other object in the scene. This is also the component we need to shrink down whenever the projectile hits it. Then we have other actor. This parameter here refers to the thing that hit. Then we have other component. This refers to the component of the other actor, such as a mesh. We have normal impulse, which is the direction of the hit. And we have a hit result called hit. This provides a lot of information about the hit, such as the location of where the hit occurred. So this function onHit is going to run whenever the projectile hits something. And you can see we already have some default code here. We see we are only adding impulse and destroying a projectile if we hit a physics object. So here we're checking for if the other actor is not null. The other actor is the thing that hit. And if the other actor is not equal to this. So making sure that a projectile didn't hit itself. And if the other component is not null, remember the component, this refers to the component of the other actor. And the other component is simulating physics. So that means that the object has to have physics enabled for this onHit function to actually execute the code in the body of this if statement. So if all of these conditions pass as true, then we'll enter the code in the if statement's body. And what we're doing here is we're adding an impulse at a location of the actor. So we're just moving the actor that was hit. We're doing that by adding some velocity or speed to it. So that's why the cubes bounce whenever the projectile hits it. Then we're calling destroy, which is going to destroy the projectile that hit the cube. Because if a projectile hits something, then it's considered the end of the projectile's life. The projectile won't be able to hit two things. This is similar to a bullet going into a body. It can only really enter the body one time. Okay, so this is where we're going to add some code that's going to shrink the cube if a projectile hits it. So before we here add impulse, or after we add impulse, we're going to shrink the cube. To do that, let's write some code inside of the body of this if statement. First, we are going to get the scale of the object that was hit. And the data type of that is going to be an F vector, and we'll call this scale. To get the scale of a cube that was hit, we're going to grab the other component, which is the component that was hit, and we're going to grab its function get component scale. All right, here then I am going to take the scale and I'm going to multiply it by 0.9f. So this means I'm going to reduce it by 0.9 or 90% every time it's hit by a projectile. All right, here we go. Now we have to actually apply that change to the object. So we're going to grab the object, which is other components, and we're going to call the function setWorldScale3D. That is going to change the scale of the object. And we're going to change it by a value of scale. So we're just going to set it to a new value, and that new value is going to be scale, which is 90% of the component's previous scale. So it'll be 90% smaller each time. All right, and then that is going to, just like that, reduce the scale of whatever object was hit. As long as all of these if statements pass as true, then the object will be scaled down. And this destroy destroys the projectile, not whatever was hit. So we can already test this out by saving all of the files that we edited, which really is just this one file that we edited. Then we're going to click this button, Local Windows Debugger, or Debug and start debugging. You can also use the keyboard shortcut F5. So I'm going to press that. That is going to build and compile my solution here. And it's also going to open up Unreal. And this way I'm going to be able to see the changes made to my file here. I'm going to see those changes reflected in Unreal. All right, so let's go and launch Unreal. We're going to be able to see this time when we hit play in Unreal, as long as our solution is still running in Visual Studio. So you want to make sure it's still in debug mode in Visual Studio as you hit play in Unreal. Okay, great. So here is my same project. I'm going to press play. And this time, look at that. Every time I press my mouse button, I fire a projectile. And look at that. Every time a cube is hit, it gets smaller. But if I hit a wall, it doesn't get smaller. We can also turn off sound. So let me just escape this. And I'm going to go back into Visual Studio and stop the build. To turn off sound, go into your first-person shooter character.c++ file and just Control F for sound. Here we have a function being called that plays a sound at a location where the fire sound or firing a projectile is called. So what we can do is we can just select all this and comment it out. For example, by hitting Control K followed by C. That is the keyboard shortcut to quickly create a comment. Or you can just manually add the comment yourself with either these 2 forward slashes or the / and asterisk surrounding the lines. Alright, so that is just going to comment out or hide this line from the compiler. So this line will no longer be registered by the compiler. It's just here for us to read as a developer. Now if we save our file and we hit local Windows debugger or F5, then we're going to relaunch Unreal, and now we'll see that the sound will actually be gone. And at any time you could uncomment that line to bring it back. So now if I press play, I can shoot and no longer do I have any sound, but my cubes are still getting smaller. So notice I can run and shoot at a cube and it just gets smaller. We can also delete the cube when it gets too small. Let's hit escape to stop the game and then just close that Unreal editor. You can also press stop in Visual Studio and that will also close that instance of the Unreal editor. Now we can make a change inside of Visual Studio again. And every time we make a change in Visual Studio, we need to hit debug and then start debugging or just local Windows debugger in order to compile all the code that is new. Once you've compiled it one time, then it will be saved in Unreal. Okay, so let's go back into our first-person shooter projectile and go back to our onHit function. Here you'll notice we just reduced the scale of a cube whenever it was hit. So we've written our first C++ code for this game. We can also remove a cube from the game if it gets too small. So for that, I am going to add in an if statement before I set the scale of the component. I'm going to check if scale dot get min is less than a value like 0.3f. So I'm checking the value of scale with this getMin function. And anytime you're confused about a piece of code, just hover over it to get a description. For example, here we can see that getMin returns the minimum value of the vector's components. Because this scale is not just a number like 1. It's actually a vector. A vector is a series of 3 values, x, y, and z, because in our 3D game, every 3D object is going to have a scale on 3 axes, the x, y, and z. How wide it is, how tall it is, and how deep it is. So that's why scale, we need to use getMin to check its smallest value of its 3 values. So if scale reaches less than some threshold like 0.3, then we could destroy the cube. And we could put all of these numbers into variables just to make it a bit more clear what they all mean. That's something I would highly recommend for doing code optimization or cleaning up your code to make it more understandable to other people. You don't want to leave what are known as magic numbers, which are numbers that are just left here in the code without having some kind of variable or constant attached to them. For example, I could make my 0.3 into a float that I call my minimum cube size, and I could set that to equal 0.3f. Now it's a bit more clear what my 0.3f actually means, instead of being an arbitrary number that might be confusing. So if our scale of the other component is less than the minimum, then let's go ahead and destroy that cube. So I am going to call other actor, and I'll call the destroy function to destroy that. Notice this is different from the destroy function we already have, which refers to just this class, which is the projectile. If you just have destroy here, it means we're destroying this class or object, which is a projectile. But if you're calling other actor destroy, then we're actually destroying the other actor. Alright, so there we go. We can now test that out. We're checking if our scale min is less than minimum cube size. Notice that, however, we still have this line that sets the other component. So you have to think through this logically. How are we going to set the scale of a component if it's been destroyed possibly? Well, for that, what we're going to do is append here an else statement. Okay, so I'm adding here an else statement, which is only going to run if the if statement does not run. And in that case, I can set the world scale of that cube. Otherwise, I can't set the scale of the cube because it's been destroyed. And we can't change the scale of something that has been destroyed. Also note, typically with formatting your code, you want to have a bracket on its own line. It can be different at each company, what they prefer in terms of their code formatting. But this is the most popular formatting you'll see, where you have each of these brackets on their own line, just because it makes the code easier to read. Let's save everything and hit debug again. That is going to compile our changes to the code and then launch Unreal. it's going to launch our Unreal project with those compiled changes. And now we're going to see whenever we hit our cube and it gets below that minimum threshold, the cube will actually be destroyed, which means it will be removed from the world outliner. Here we go, my instance of Unreal has launched, which means I can press play, and then I can attack a cube, and let's just attack it until it gets extremely small or reaches that 0.3 value. Let's see, that's quite small then that it's getting. Aha, and there we go, it has been deleted. So 0.3, that is quite a small ways for it to get, but eventually it is deleted once we hit it enough times and it gets to 0.3. Let me just chase after it. Right, run around. There it is. Once it gets to a value of 0.3, it's gone. Okay, so we can even hit one of these cubes and chase it around. Then let's just grab control of our mouse cursor with Shift FN F1. And now I can actually go ahead and let's see, let me just get it again. I can take a look at all of the cubes in my world, using my world outliner here. Okay, and if I find this cube, then I can check its scale in the details window. So we see we have 1.5, then 2.5 normally, then 1.5 for other cubes. So basically we'll see that none of the cubes will be able to have a value that is less than 0.3. And feel free to play around with that. You could have it be larger than 0.3 just to make it easier to test. But there you go, you can see it's removed. And in the world outliner, the cube will also be removed from that world outliner because it's been completely destroyed once it reaches less than 0.3. And we could even go around and just destroy all the cubes, and you'll see they'll all be destroyed from the world outliner if you manage to hit them. Of course, it does get harder to hit them as they get smaller, so it would be an easier game here if we had a larger threshold. Alright, and that is how we can write our first bit of C++ code for our game. Join me coming up. We're going to continue this project, and next up we're going to start building out some enemies. These are going to chase our player around, and the player will have to destroy them. Alright, so coming up next, we're going to begin by building an enemy C++ file and writing some functionality for that enemy to move around on its own, and later on to spawn randomly in the game. I will see you in the next section.